Hello and good day to you. So today I'm redoing this video I did on my MTEM, which stands for Multi-Task Evolutionary Model. My idea here was that it's better to have more than one AI and network them together than it is to just do a single task at once, and I wanted to try and go down this route using evolutionary dynamic programming to implement which AI would connect to which one. And make it very simple that the testing and implementation of the model was all automated. So, I've just been running it in the background, testing it. Originally, I did this video and I came away and thought that I should really double check my numbers. And I did find that out of the 4 graphs I showed, only one of them had a mistake on them. So I redid the video and took the previous video down to correct these mistakes. The idea here is that each of the neural networks is individual, it's doing its own individual thing, it's got its own individual task, but they become interrelated by sharing information across to each other, and what will be shared is chosen by a process of evolution. So we set them the task running, the genetic algorithm runs the test, and will, based on same underlying concepts in all genetic algorithms, i.e. It has a bunch of flags for what will connect to what, and it just moves through connecting stuff, and it adds new stocks into the model over time, so the entire model becomes larger and more complicated over time, and includes more stocks and a bigger process. I had to really get my head around some different ideas to do this. So where this is coming from is things like pair trading, the idea that 2 different stock prices can be interrelated either because there's a convergence to the average mean price for a given industry, i.e. if you have 5 companies and they all do the same thing, you'd expect them all to be roughly priced similarly in terms of their stocks, i.e. unless one of them is really clearly better, there's no reason to expect all those stock companies to be different. You'd expect them to all be the same because you're owning the same company. But there's also what they call continuous stock flow continuity graphs, which are a more complicated way of saying that one company might be a supplier of another, and by using some sort of values that we take from that company and that we've observed from that company, we can create proxy approximations of different values for inputting into an estimation of the health of different companies within the network. There's also a new agey concept that I went down thinking that this might be a little bit like Nietzsche and consciousness, which was one of my original sort of inspirations, but I didn't go much further down that. That being said, I do feel that something about this that I've noticed is the efficiency does seem to stack up as you add more models into the network, so doesn't disprove that, actually does go with that concept. More AI is good. You can see from this that it works, that the MTEM outperforms testing a non-aggregated, non-linked model, i.e. when the MTEM doing its sideways sharing of information across the network outperforms but when I split them up into individual neural networks and did them on their own. And this is to say the MTEM could arguably outperform the sum of its parts. So my first MTEM wasn't huge, and I just built it larger. As I say, the genetic algorithm does its own thing at its own time. I then took it apart and tried to test it from single sort of just from a starting point of training to see whether training requirements was exponential. There was a little bit of proof of that, so it does sort of seem that the MTEM, a big MTEM, takes a little bit more longer to train, but the big important thing for me to show was that I wasn't looking at a exponential training time that would make me sit there going, well, great, I can add another neural network into the network, but it's meaning that I've got to train the whole thing 3 times longer every single time I add a single neural network. That wouldn't be very good. I found that that's not true, so there's sort of reason to believe that you can build bigger models which do more complicated stuff. So what did I conclude about this? So my conclusion is that you can sort of get better results by, doing this connection of multiple neural networks into the larger networks. I had this sort of theoretical thing of, well, what happens if we ever got to the point where a single network contained all the marketplace data, i.e. trading on the Forex market, trading on all the single stock markets data. And I don't think it's practical because of the slight increase in training time. I think a network with 900 different AI as part of it probably would take a long time to train, but it probably isn't so exponential that you couldn't get it done over a long time if you wanted to sort of start evolving and building that model. Like I sort of jokingly think of this as a self-driving pension fund, i.e. I don't think this means that somebody using it cannot lose money. I'm sure there are disadvantages. We are taking the past and building a model from it, and that doesn't always translate to exactly how the future behaves. But the past is the only method of analysing what might happen in the future. All experience is analysis of the past. Interestingly, I noted some of the highly trained models are more Markovian than, focus less on historical data, take less historical data in, and focus on what is happening sideways with the other stock, and evolve to do that, after a few different tests. But I could see this as sort of a smart expert system that if you were a non-expert, you could have, an artificial intelligence that, advises you on your trading process and gives you an estimate of how good or bad a move is, which could be good. We could get more people into the market. The bad is I'm always certain that somebody in banking has always probably done something similar like this. Speculation, but you never assume that you got there first unless you've got evidence. I don't know how far you could extend this. I don't know if there's an upper limit, or if there's a limit you crossed it goes down in effectiveness. I don't know at what point it might be overtrained, because it's possible that it starts to, like all AI, over remember the precise details. So who knows what point you say, well, that's enough. This isn't a high frequency trader algorithm by design, but I'm aware that neural networks have been used for high frequency trading and have been blamed for the 2010 flash crash. I think it was in Chicago, and therefore there might be a data ethics question of if everybody uses these neural network models and they don't understand them and they trade on the back of them, is that good? Is that good if there's then a crash and we sort of sit there going, well, we don't even know why the AI all made these decisions? But because this AI must contain volume data in its transaction and the current price, that could be a potential problem, that one AI could sell off a stock, and other AI looking at the same stock, then having seen the price fall a little bit, might consider it better to then carry on selling. So you could, there's a sort of a potential problem, because if they're so good at playing the game, then it doesn't. Then they sort of deepen the highs and increase the lows is sort of a potential problem that we might need to talk about. So that brings you to the final point of, well, what happens if you take all that negative stuff and go completely off the rails with it? And I'm not saying I know, but there's sort of a little bit. I felt they note that 30% of stocks and 60% of futures is currently traded under this high frequency method, and I just sort of get a bit of a sense of this could be scary in that we could end up removing human decision makers from the loop, and by continuously putting in AI into stock trading. So I just didn't want to end on that note. I actually think AI in stock markets is a massive positive. This surprised me how much better it was. There was that graph. They look quite similarly trending, but there is a slight non-linearity to one and not the other, and the gap between the two is quite large in terms of cash at some point. But I guess the only bit to say, well, this is where I can really clarify and say I think this is where it becomes a bit funny, and maybe this is not the best idea in the world. It's that if you were an absolute if you were a philosopher, you'd think that the point of the markets is price discovery, and I'm not sure AI does price discovery. They sort of play a game, and so there's this whole overwhelming feeling of this is a great thing to try and get your head around and learn how to apply AI for stocks. But I come away with that one little concern. So thanks for watching. Have a good day and a good night. Bye.